अच्छा चलिए यहाँ से स्टार्ट करते हैं कि लास्ट टाइम आई जस्ट गिव यू वेरी ब्रीफ इंट्रोडक्शन अबाउट इलेक्ट्रोलिसिस। वो मैंने कहा था कि इट्स उसका उल्टा है, ठीक है, इलेक्ट्रोकेमिकल सेल का। इट्स एग्जैक्टली द ऑपोजिट ऑफ एन इलेक्ट्रोकेमिकल सेल. In an electrochemical cell, you have a chemical reaction and which produces a movement of electrons, ठीक है. While in electrolysis, it's the opposite. Battery पहले से है, ठीक है. The movement of electrons is already uh, उसकी जो direction है, that's already set. The negative, ठीक है, छोटा वाला जो terminal है, that's negative, that's cathode. So the battery is producing electrons, and the other side, the battery is pulling electrons. So whatever happens over here, whoever comes over here is going to gain electrons. Whoever is on the other side, that's going to lose electrons. ठीक है. तो यहाँ पे चॉइस नहीं है, ठीक है. रिडक्शन इज ऑलवेज गोइंग टू हैपन एट कैथोड एंड ऑक्सीडेशन विल ऑलवेज हैपन एट एनोड. तो ये वही ओ लेवल्स वाला इलेक्ट्रोलिसिस है, ठीक है. there's nothing, I mean not in this case, there's pretty much nothing that new. एक और मैं कर लेता हूँ इसी तरह का कि लेट्स से एल्यूमिनियम ऑक्साइड है. तो लेट्स try and do the electrolysis of aluminium oxide. 1 second. ये पता नहीं क्यों स्टक हुआ हुआ है. Just hold on 1 second, इसको मैं रिस्टार्ट कर लूँ. खुद ही बंद हो गया. ठीक है, मेरे ख्याल से इस वाले में नोट्स बहुत ज्यादा हो गए, इसलिए वो अब हैंग ही. चले. हाँ ठीक है, नाउ इट्स मूव. अच्छा, सो आई जस्ट क्विकली बस जल्दी जल्दी खत्म करें ताकि थोड़ा पास वापस कर लें. तो हाँ. अच्छा, एक एल्यूमिनियम ऑक्साइड का इलेक्ट्रोलिसिस कर लेते हैं क्विकली. अच्छा नहीं, स्टिल गेटिंग स्टक. एक सेकंड में ना वो दूसरा स्टार्ट करने एक और पेज ऐड कर लूँ. उसके ऊपर पेज पे लोड बहुत ज्यादा था. 1 second. बस ठीक है, यहाँ पे स्टार्ट कर लेते हैं. अब ये कि so again we just doing electrolysis. I'll just quickly do one electrolysis, which is let's make it aluminium oxide. तो aluminium oxide में क्या है कि there's again there's going to be cathode and anode. ठीक है, तो this is cathode, the other one is our anode. अच्छा, ये बीच पे negative and positive. अच्छा, so what happens is let's say it's aluminium oxide and it's molten and it's liquid. So it's going to have two ions. One is aluminium, which is +3, and the other one is oxygen, which is -2. जो positive anode है, that's going to the battery is going to be pulling electrons, ठीक है, at the positive anode. So it will be pulling electrons away from the oxygen ions as well. And on the other side, the battery is giving electrons. So it will be giving electrons to aluminum ions, and that's pretty much it. Okay, reduction will happen. Aluminum ions will gain electrons. That's +3. It will gain how many electrons? 3 electrons to form aluminum. The other side, oxide ions will lose electrons. Diatomic hai, so it's going to lose 4 electrons, and it will become oxygen atoms, but 2 of them, okay, diatomic molecules. That's it, okay. So cathode के ऊपर there is reduction, anode पे there is, तो यहाँ पे reduction, anode पे there's going to be oxidation. ठीक है, so absolutely nothing new, ठीक है, it's the same basic concept. इसके अंदर just remember that there's certain elements that are diatomic, तो उसकी list बना लेते हैं. Diatomic, who's diatomic? Diatomic is group 17. Entire group 17 is diatomic. Then you've got hydrogen, oxygen, and nitrogen. ठीक है, 3 of these, they're all diatomic. बस ठीक है, तो ये that's electrolysis. ठीक है, that's electrolysis of molten electrolytes. ठीक है, electrolytes का basic definition, electrolytes अच्छा पता नहीं क्या हुआ, ये फिर क्रैश कर रही है. जस्ट अ सेकंड. अच्छा, electrolytes की जो electrolytes are those substances. So they are substances that decompose when what happens? When a current is passed. This is यहाँ पे aluminum oxide got decomposed. You have electrolysis is decomposition of a substance by passing current. So यहाँ पे aluminum gained electrons, oxide, I mean, two different products are formed and it decomposed. Okay, so substances that decompose when a current is passed. Most of those substances are what? They've got free moving ions. So they would be aqueous or molten molten ionic compounds. Or कौन से होते हैं electrolytes? Electrolytes are anything that's got free moving ions. So it's not only ionic compounds that form ions. ये भी होता है sometimes, or covalent molecules that hydrolyze in water and form ions. So that hydrolyze in water and eventually they end up forming ions. लेकिन वहां भी बात खत्म नहीं होगी कि sometimes it could just be a covalent molecule as well. ठीक है, but so mostly it's substances that have free moving ions. लेकिन मैं explain करता हूँ, ठीक है. So now I'm going to just make things a bit more complicated. ठीक है, so next thing is I'm going to do an electrolysis जहाँ पे it's not just one element gaining electrons, one element losing electrons. ठीक है, that's too easy. तो अब अगले step पे चले जाते हैं कि I've got NaCl aqueous. ठीक है. So the idea is, as I remember, इसके अंदर electrolysis के अंदर ना you can just get away with O levels things as well. ठीक है, you studied in O levels how to do electrolysis, so you can pretty much apply the same thing as well. क्योंकि जो advanced वाला part है ना, जो A2 वाला part है, that could kind of get a bit more complicated. The O level stuff is slightly simpler. ठीक है, तो इसको मिटाते हैं, and what I'm going to do is I'm going to take I'm going to do electrolysis of कौन सा था, NaCl aqueous, let's say. तो अब इसमें देखते हैं, now you're going to have multiple substances. ठीक है, you got a battery, you got NaCl aqueous in the solution. तो cathode पे there's going to be Na+1 and there's going to be Cl-1. ठीक है, so one ion goes to cathode, the negative cathode, the other one goes to the positive anode. ठीक है, अब मुझे कोई ये बता दे कि apart from in aqueous state, what other substances will be at cathode and anode? NaOCl के अलावा क्या होगा?
Study H plus and OH minus ions.
ठीक है, so there's H+1 and OH ions, right? Now in O levels you studied that, ठीक है? Hopefully everyone studied कि भाई वो there's water, so there's going to be H+1 and OH ions, ठीक है? Technically there's not a lot of H+1 or OH ions. Um, so in aqueous state, just remember okay, you do have H+1 and OH ion, but the fact is that water ionizes very less. ठीक है, water ionizes very less, so there's not a lot of H+1. There's actually almost negligible H+1 in OH ions. इसकी जो concentration होती है ना, that's barely 0.000 कितने 7 zeros I think 1 2 3 ठीक है 7 पे that's mole per dm cube, right? So it's kind of almost I mean the ions are almost non-existent, okay? So what we're going to do is we're going to assume that water does not ionize. But since water is a neutral compound, so water is everywhere. Water आपके cathode पे भी है, ठीक है, and water is also present at your anode as well. ठीक है? So is this part clear? कि अब मैं technically you remember you can get away with your O level stuff as well, ठीक है? You can most of the questions you can pretty much answer using your O levels knowledge as well. क्योंकि रिजल्ट तो सेम होगा एंड में, बट दिस इज टेक्निकली वी डूइंग A2 नाउ. तो अच्छा मुझे बताओ ये क्लियर है ना कि वाटर वाली बात क्लियर है कि व्हेन यू डू इलेक्ट्रोलिसिस ऑफ aqueous solutions don't take H+1 or OH ions, think of it as just water on both sides. Is that clear?
Yes, sir.
Yes, sir.
अच्छा अब अगला पार्ट ये कि तो इलेक्ट्रॉन्स यहाँ से ट्रैवल करें कैथोड, so who's going to gain electrons? Now you've got two options. Now you've got Na+1 or water, ठीक है? The question is out of these two, who's the one who's going to gain electrons? Or remember, cathode के ऊपर the only option that you have is about gaining electrons. I mean, there's no option to lose electrons क्योंकि बैटरी वहां से electrons भेज रही है, तो और तो कोई choice ही नहीं है, उसने gain ही करना है, ठीक है? So there's only one option which is, so lose करने वाली बात ही नहीं करनी. So who gains electrons out of these two? We know that who gains electrons, the one that's got the higher potential. The higher potential one is the one that likes to gain electrons. तो मैं Na+1 और water की I'm going to look for equations where they're actually gaining electrons, ठीक है? तो किधर की my data booklet? So I'm going to open up Na+1 and H2O, and I'm going to look for the reaction only in the forward direction. Because forward में it's going to gain, backward में it's going to lose. So I'm only interested in gaining electrons. So Na कहाँ है? Na is Na is over here. So I've got this equation where now this equation I've got Na+1 where Na+1 is. So I got Na+1 gaining electrons, right? And that's minus 2.71 volts. Okay, only focus on gaining electrons. The only focus is that the equation should be in the forward direction. Na+1. There's no point in writing the reversible sign because direction का तो question ही नहीं है ना. So Na+1 gaining electrons, that's Na, that's the E0 for that is what? It's minus 2.71 volts. Then I have to look for equations where water is gaining electrons. I need to find out equations because water is the other option. So if I have a look at the data booklet again, so I need to find forward में देखना है where water gains electrons. There's this यही एक है, ठीक है? That's so I got water plus 2 electrons. It forms H2 and OH ion, so that's minus 0.83. So that's water gaining electrons कहाँ गया? So 2 water plus 2 electrons और क्या बन रहा था? H2 plus 2 OH ions, right? And the E0 for that was minus 0.83 volts. अच्छा अब दोनों का ऑप्शन आ गया. Na+1 gaining electrons, water gaining electrons. और यहाँ पे मैं let me write a note as well. So the equations should be I mean, you have to think about it in the forward direction. ठीक है, only where they gain electrons. अब ये दो options as you got, so the electrons are coming in. Who's got the better chance to gain electrons? Who's got the higher potential? तो वो ये water है, ठीक है. Water's got the higher potential, so it's going to be water that gains electrons, and that's what we're going to go for. ठीक है, so the answer is that it's this one, which is the higher potential. ठीक है. तो idea clear है कि क्या करना है कि cathode पे you're going to look for the one that's got the high E naught. Is that clear?
Yes.
और प्लस
Yes.
ये वही इक्वेशन बन रही है, H2 गैस बन रही है, ठीक है. लेकिन वो O levels में वो था कि it was with H+1 gains electrons forms H2, and I told you that in fact you don't really have a lot of H+1. In fact you actually have water, and water gains electrons. Result वही है, ठीक है. It's वही O levels वाली result है. Just the fact that it's not really H that's gaining electrons. अच्छा, दूसरी side पे you're going to do the reverse. ठीक है, so you're going to look for the equation in the backward direction क्योंकि वो loss का देखना है. So we have to find equation in the backward direction. और कौन से दो options है? I've got I have to figure out कि इन दोनों में से ना Cl-1 और water में. Now I have to figure out who loses electrons. And we know कि lose कौन करता है? That's the one that's got the lower E naught. ठीक है, उसे lose करना है. So water and Cl-1. Cl-1 is easy कि वो एक ही equation है Cl-1 की. Losing electrons, right? So I've got Cl-1 and it's ये backward में it's losing electrons. So I'll just look for the equation in the backward direction. एक और भी है Cl-1 losing electrons, लेकिन it needs OH ions. We don't have any OH ions, ठीक है, तो इसी को ले लेंगे. Cl-1 losing electrons 1.36. So I'm going to write it in the same way. So Cl-1, क्या 2 Cl-1 loses electrons, forms Cl2 plus 2 electrons. And the potential for that is 1.36 volts. अच्छा, फिर there's another one कि I need to find equations for water losing electrons. So if I go and have a look, backward में water को ना right side पे होना चाहिए, water losing electrons. Not this is water gaining electrons. I'm looking for equations जहाँ पे वो lose कर रहा हो water, ठीक है. So I found two equations. There's this one, water losing electrons. And there's एक और भी है. There's this one that's water. That's again water losing electrons, right? So one is 1.7. दोनों को लिख लेते हैं. पहले वाले में 2 water. Let me just write it down. So I've got 2 water. They lost electrons. पता नहीं क्या हो रहा था. H2O2, 2H+1, 2 electrons. H2O2. So it would form H2O2, 2H+1 plus 2 electrons. And I think that's 1.77 volts. And then I had another one as well. There was another equation for water losing electrons, and that was forming what? वो था O2 plus 4H plus 1 plus 4 electrons, right? This one. And that's 1.23 volts. तो यहाँ पे जो भी substance है ना, I found equations where they're losing electrons, ठीक है? Remember, you have to find the equation only in the backward direction where they're losing electrons. And I found out 3 equations. And I figured out that who's going to lose electrons? The one that's got just किसके सबसे ज़्यादा chance है? Just the one that's got the lowest E naught. तो lowest कौन सा वाला है? ये water ही है, ठीक है? तो lowest भी end में water ही आया है, ठीक है? It's water that's losing electrons. तो और वही आ गए. We got oxygen gas being produced at one end. तो bubbles बनेंगे, ठीक है. The other end we'll be getting H2 gas being produced. तो clear है ये the E naught values as applied to electrolysis. Is this clear?
Yes.
Sound clear है? वो मैं
Yes,
साथ
sir.
ठीक है. ये क्या question है?
Yes, sir.
हाँ.
Wasn't there a case where when the halogen ions compared to water, the halogen ions would be favored more?
हाँ, अभी मुझे बताओ कि right now who's got the greatest tendency to lose electrons? That's
That's
water.
water, yes, sir.
अच्छा, so when was the case, always when was the case when chlorine got discharged? मतलब NaCl कौन सा NaCl होता था? When chloride ions would get discharged.
Was it the concentrated one, sir?
ठीक है. So the thing is that I mean, O levels you studied that if वो क्या था, NaCl is concentrated. ये question भी पूछेंगे. Then Cl ions are discharged. और उससे क्या होता था? So basically your equation was that it was Cl minus 1. They lost electrons, they would turn into Cl2 plus 2 electrons. You would get a greenish yellow gas. Now the question is क्या फर्क पड़ता है? If NaCl is concentrated, why does chlorine get discharged? Even though chlorine's got a higher potential, chlorine's got a lower tendency to actually lose electrons. So what happens is, ये हमने कल पढ़ा था कि अगर Cl ions are concentrated, so the reason for that is ये reaction है Cl2 plus 2 electrons. मतलब डेटा बुकलेट में ऐसा लिखा हुआ है 1.36 volts, right? So if this is concentrated, where would this equilibrium shift? Backward or forward? क्या होगा अगर मैं NaCl concentrated use करूंगा? If Cl ions are concentrated, तो where would the equilibrium shift?
To the left.
ठीक है, लेफ्ट की तरफ. और हमने क्या पढ़ा था कि अगर equilibrium left की तरफ shift होगा तो it's going to produce more electrons and it's going to become more negative, right? So let's say it becomes 1.15 volts, right? तो concentrated के अंदर this electrode will have a much lower potential. So 1.15. अगर 1.15 हो जाता है तो out of the three, if it's not 1.36, if it's 1.15, then that will be the lowest potential. ठीक है. तो chlorine की tendency to lose electrons increases if it's concentrated. So तो इस केस में ये हो रहा है, ठीक है. And I'm going to write that down के reason के the equilibrium, it shifts to the left. And the new electrode potential becomes lower than E naught. And overall, what happens is that at anode, ये जो Cl2 Cl ions वाला electrode है, ठीक है, will have the smallest or lowest potential and is going to be preferentially discharged. ठीक है, is this clear?
Yes, sir.
तो ये they're going to ask you about this, ठीक है. They're going to ask you, Tasneem, Saleh, is this clear?
Yes, sir. Yes, sir.
अच्छा, तो ये क्वेश्चन, अच्छा, और ये इशू जो है ना, दिस इज ओनली विद, I mean, all of us में भी ना यही पढ़ा था ना कि you studied कि it's only an issue, it's only an exception for chloride, right? Because the electrode potentials are very similar for water and for Cl. तो इन दोनों के बीच में ना स्विच कर जाता है अगर वो conditions हल्की सी भी चेंज होती है ना, तो water की बजाय ना it's Cl that starts getting discharged. थोड़ा सा dilute होता है, water will start getting discharged. It's not an issue with other, I mean, it doesn't happen in other situations. क्योंकि the difference जैसा right side पे cathode पे it's always going to be water क्योंकि there's a huge difference between the potentials. तो आप अगर concentration ऊपर नीचे करोगे भी ना तो the potential the higher will still be the higher one, the lower will still be the lower one. I mean it's not because the difference between the potentials is a lot. ठीक है तो बस ये so this is electrolysis ठीक है and we can just do a few more question वो एक copper sulfate का आता है ठीक है so let's try and do that. अच्छा copper sulfate aqueous what is going to copper sulfate aqueous होगा वही electrode है अच्छा ये बस जल्दी से बनाए अच्छा cathode anode copper sulfate में क्या होगा there's cathode ठीक है this side negative you got copper ions +2 और दूसरी साइड पे you got SO4 -2 ions ठीक है और water होगा ठीक है I mean you can go with H plus and OH ions लेकिन it's water which is not ionizing a lot ठीक है तो ये positive side है one side is going to lose electrons the other side is this side is going to gain gain electrons the other side is the one that's going to lose electrons तो equations क्या है I want equations अब cathode पे I want equations में copper +2 और water gaining electrons तो copper +2 की I think दो equations है copper +2 I need to look for copper +2 gaining electrons forward में तो copper +2 is एक ही equation है copper +2 the other one is उससे नीचे ठीक है so it can either gain 2 electrons or it can either gain 1 electron ठीक है तो इसको बस snapshot ही ले लेते हैं अच्छा ये इक्वेशंस दो आ गई अच्छा गलत वाली कर दी है वो कॉपर +1 की कर दी है सॉरी नीचे वाली दो थी ठीक है कॉपर +2 गेनिंग इलेक्ट्रॉन्स वाटर गेनिंग इलेक्ट्रॉन्स ठीक है जैसा क्विकली वाटर गेनिंग इलेक्ट्रॉन्स इधर ही था कहीं अच्छा ये जो मार्क किया हुआ है ठीक है सो वाटर गेनिंग इलेक्ट्रॉन्स दैट्स -0.83 अब इन सारों में who's going to gain electrons right so cathode gain electrons right कौन है highest E naught So in this case, it's going to be the top one, right? It's copper. That's the highest E naught, ठीक है? तो ये वाली जो है ना, that's the one. और ये उसका potential है. ठीक है, clear है? Is this clear कि फौरन पता लग गया? उधर असल क्वेश्चन में तो आपने बस डेटा बुकलेट के ऊपर मार्क करके you can just figure out who gains electrons, right? Is this clear?
Yes.
और फिर दूसरी साइड पे water and SO4 -2 is losing electrons. So backward में देख रहे हैं losing electrons. So कहाँ पे water losing electrons? तो ये दो water की होगी ठीक है वही पुरानी तो ही है अच्छा एक इस नीचे कर रहा था एक ये होगी और कौन सी राइट साइड पे वाटर होना चाहिए, ठीक है, वाटर लूजिंग इलेक्ट्रॉन्स, द अदर वन इज दिस वन, ठीक है, वाटर लूजिंग इलेक्ट्रॉन्स, okay, 1.23. Who else? SO4 minus 2 losing electrons. So do I have SO4 minus 2 backwards? I've got SO4 minus 2 over here. It's losing electrons. ठीक है, तो वो SO4 minus 2 की भी, that's 2.01 volts. अच्छा, तीनों आ गए. तो who's going to lose electrons at anode? The one that's got the lowest E naught. तो इंसानों में who's got the lowest E naught? That's again ये water वाली यही है ना. हाँ, तो it's this equation. बट इन द बैकवर्ड डायरेक्शन, ठीक है, दिस इज, मतलब मैंने उस तरह उठा के लिख दिया, बैकवर्ड है, वो वाली जो है दैट्स फॉरवर्ड, ठीक है. वहां पे रिमेंबर रिवर्सिबल डजंट मेक सेंस, ठीक है. कैथोड इट्स ओनली गेन ऑफ इलेक्ट्रॉन्स एंड एट एनोड इट्स ओनली लॉस ऑफ इलेक्ट्रॉन्स, ठीक है. तो ये क्लियर है, इज दिस क्लियर?
Yes, sir.
Yes, sir.
अच्छा, तो ये इसका वो भी लिख लेते हैं, वो उसमें क्या पढ़ा था, कॉपर सल्फेट एक्वस. सो कॉपर एनोड डिसॉल्व्स, राइट? नहीं, सॉरी, कॉपर एनोड, एनोड तो कॉपर का है ही नहीं. दिस इज राइट नाउ इट्स इनर्ट प्लैटिनम इलेक्ट्रोड्स, ठीक है. तो अभी कोई उसमें वो just inert platinum electrodes. So here what you're going to see is pure copper gets deposited at anode. Anode भी cathode. और वहां पे ऑब्जर्वेशन क्या होगी, bubbles of O2 gas are seen. What happens to the solution? The solution क्या होता है solution? What will happen to the solution वैसे, by the way, जब ये electrolysis हो जाएगा?
Will become colorless.
ठीक. अच्छा, so it's going to become colorless. Why? क्योंकि एक साइड से copper is gone and the other side वो क्या चला गया, water is gone basically, ठीक है. अच्छा, वो वाटर फिर, वाटर जो है ना वो फिर प्रोड्यूस कर रहा है H plus ions, right? So you basically end up as H, I mean the water basically gets converted into O2, तो bubbles बन के निकल जाएगा. The water will get converted into H plus, so basically you're left with H2SO4, ठीक है. So the solution turns from the solution का लिख लेते हैं. As the solution turns from CuSO4 aqueous to H2SO4 aqueous. So it turns colorless. ये blue था, and this one over here is colorless. अच्छा, now exactly same thing वो करना है कि exactly same thing. Now I'm going to use, मतलब ये टेक्निक ना जो अभी ये सीखी है ना, we're going to use copper electrodes. अच्छा, same one. अच्छा, except कि अब यहाँ पे ना, अच्छा, except for no longer platinum electrodes, but now we're going to use copper electrodes. So what difference would that make? ठीक है, ये मैं हटा दूं पुराना. अच्छा, सॉरी, मैंने स्नैपशॉट ले लिया, एक सेकंड रुकना. अच्छा ये क्या था, ये वो using copper electrodes. So now, so this is made out of copper, and the other electrode is also made out of copper. TK, there is absolutely no difference. TK, it's the same exact electrolysis. So cathode पे तो absolutely no change. क्योंकि metal कभी भी, there's no equation for metal gaining electrons. So the copper metal being there is absolutely, I mean, there's no reaction where a metal gains electrons. Data booklet भी search करो, you won't find copper gaining electrons. It's either going to be copper ions or water, ठीक है, इन दोनों में से. So it's going to be exactly the same. But at anode, when you're losing electrons, तो water could lose electrons, SO4 minus 2 could also lose electrons, लेकिन अब copper metal जो है ना, उसकी भी equations आ जाएंगी where it could also lose electrons. So I've got multiple equations, two of them, ठीक है. So the number of equations over here have to increase. ये पिछली हटा देते हैं. अच्छा, so the thing is कि copper itself is now a candidate for losing electrons. तो यहाँ पे अगर जाके देखोगे तो अच्छा, तो कॉपर किधर है? कॉपर losing electrons, two of them, I think. हाँ, राइट साइड पे. तो इसको अगर बैकवर्ड में देखोगे ना, these two equations, ठीक है, think of them in the backward direction. So it's copper losing electrons. It could either lose one electron or it could lose two electrons. So you've got two extra options. दो और candidates आ गए. तो it's either SO4 minus 2 or H plus 1. तो उनकी तो ये equations थी, वही पुरानी वाली. SO4 minus 2 losing electrons, water losing electrons, right? Backward में. And फिर ये copper का बना हुआ है, so that could also lose electrons to the battery. So you got two equations for copper as well. Now, who's going to lose electrons? The one that's got the lowest E naught. So in this case, who's got the lowest E naught? It's the last one here. Okay, that's the, so that's the lowest E naught. So what will happen is कि एक साइड पे अब जो डिफरेंस होगा, कॉपर एनोड डिसॉल्व्स, copper plus 2 ions are formed. So one side is actually increasing the amount of copper ions, और दूसरी साइड पे क्या हो रहा है? वही हो रहा है, copper is getting deposited and copper ions are discharged, yeah, are removed from the solution. So net effect क्या होता है? Net effect, nothing happens. Nothing happens to the solution. Solution remains copper sulfate. So nothing really happens to the, अच्छा ये वाला क्वेश्चन क्लियर है? Is this clear?
Yes.
ठीक है. तो ये वो एक्टिव इलेक्ट्रोड्स का भी हमने कर लिया कि why did copper dissolve? Because it had the, I mean, greatest tendency to actually lose electrons. Either सारों में ना, it was the copper metal itself that wanted to lose electrons. और वहां पे why did copper ions gain electrons? Because out of all of them, water और copper ions में competition था. It was copper ions that had the greatest tendency to actually gain electrons. ठीक है. तो ये क्लियर है ये वाला पार्ट?
Yes.
और बस ठीक है. अब वो मैं I'll just open the data booklet, not the data booklet. I want to open the, मतलब मेन चीज हमने कर ली है. एक सेकंड, सिलेबस मैंने सॉरी इस वाले लैपटॉप में डाउनलोड नहीं किया. 977 सिलेबस. हाँ अभी तक तो हम इसी पे हैं। बस 1 मिनट रुक जाओ, ये खुल जाए। पता नहीं मैंने डाउनलोड। अच्छा 1 सेकंड, मेरे ख्याल से मसला पता लगा। चलो सॉरी, सिलेबस अभी खोल नहीं रहा। मैं सोचने दो, और इसमें क्या था, कौन सी चीज हमने मिस, कुछ छोटे छोटे पॉइंट्स हैं जो शायद हमने मिस किए होंगे। नर्स इक्वेशन भी होगी। और क्या था, इलेक्ट्रोलिसिस भी डन विद, ठीक है। वी कैन स्टार्ट विद पास्ट पेपर्स। एक कैटलिस्ट है, वी कैन डू दैट वन, ये बल्कि कर लेते हैं, या उसको रिएक्शन काइनेटिक्स में स्टडी कर लेंगे, कैटलिस्ट का उससे ताल्लुक है, तो वी कैन स्किप दैट। चलो अभी ये ना खुल ही नहीं रहा, ये द सिलेबस इज नॉट फॉर सम रीजन नॉट ओपनिंग। इसके इसका बस रिवीजन करना, ठीक है। I'll share a PDF नेक्स्ट टाइम, we'll start with questions, ठीक है। वो सिलेबस खोल जाएगा तब तक, अभी नहीं खोल रहा। अच्छा, we'll start with questions. I'll just summarize everything just very very briefly कि हमने स्टार्ट से क्या किया था। स्टार्ट से हमने इसमें कोई बहुत ज्यादा, ये तो दूसरा वाला खुला हुआ है, इतनी ज्यादा इसमें रॉकेट साइंस नहीं है। जस्ट रिमेंबर, जस्ट अ क्विक रिकैप ऑफ एवरीथिंग, ठीक है। जस्ट रिमेंबर के हायर पोटेंशियल गेन्स इलेक्ट्रॉन्स, लोअर पोटेंशियल लूजेस इलेक्ट्रॉन्स, ठीक है। एक तो वो बैलेंसिंग रिडॉक्स रिएक्शंस, ठीक है। यू शुड नो कि इलेक्ट्रॉन्स गेन एंड लॉस शुड बी इक्वल, ठीक है। ऑक्सीडेशन स्टेट्स एक्सेट्रा, यू शुड नो हाउ टू कैलकुलेट ऑक्सीडेशन स्टेट्स। The other part is कि drawings are very important, ठीक है। A lot of questions on drawings, you have to know how to draw. There are 3 different types of electrodes and you should know how to sketch those electrodes. Those potentials, those electrode potentials are measured with respect um, to a hydrogen electrode. ये आपका hydrogen electrode है, ठीक है। So always remember how to draw the drawing, salt bridge, etc. Everything. Where would the electrons flow in what direction? ठीक है, एक तो वो था. Then we learned how to make equations. ठीक है, higher gains, lower losers. उसमें फिर वो हमने we did complicated equations as well. और फिर end में ना we once we did the equations, उसमें there was some that were very complicated. Most of the time I told you that the reaction is going to be very very straightforward. अच्छा, वो मुझे याद आ गया कि हमने क्या चीज़ मिस की है। सिलेबस अभी भी नहीं खोला। ऐसा कोई इंपॉर्टेंट चीज मिस की है, मुझे वही फील हो रहा था कि ये मिसिंग समथिंग। ये 5 मिनट देना, ये हम कर लेते हैं। अच्छा, सो द थिंग दैट वी मिस्ड, अच्छा जो चीज मिस की है ना, वो है इट्स द फैराडे कांस्टेंट, ठीक है। इट्स मोल्स एंड इलेक्ट्रोकेमिस्ट्री। अच्छा, ये बड़ा सिंपल है, ठीक है। इट्स नॉट दैट कॉम्प्लिकेटेड, काइंड ऑफ लाइक वेरी वेरी स्ट्रेट फॉरवर्ड। मोल्स के साथ इट्स लिंक्ड विद मोल्स। अब इसमें ये कि I mean, you already know moles, ठीक है, उसके formulas, etc. So I'm not going to teach you moles. Electrochemistry. How do you link electrochemistry with that? The idea is that a simple concept है. There's one electron. क्या किसी को पता है कि क्या charge होता है one electron पे?
So is it 1.60 times 10 power negative 19 coulomb?
ठीक है, 1.6 times 10 power minus 19 coulombs, right? अच्छा, so 1.61 नहीं होता? एक सेकेंड, उसका मेरा फोन भी डेड हो गया. अच्छा, 1.6 1.6. एक सेकेंड, इसको जल्दी से. चलिए, खुल गया, वैसे सिलेबस खुल गया. अच्छा, वो इसमें अभी भी नहीं आ रहा. नहीं, ठीक है, 1.61 नहीं, 1.6 ही है. वैसे मैं वो देखना चाह रहा था कि एग्जैक्ट नंबर सिलेबस में कहाँ पे है. ठीक है. नहीं, इधर भी नहीं दिया. वो पेपर में एंड में लिखा होता है. ठीक है, तो पेपर के अंदर जब क्वेश्चन पेपर खोलते हैं उसमें एग्जैक्टली एंड पे द एग्जैक्ट नंबर इज रिटन. ठीक है. अच्छा, नाउ वेरी क्विकली, what happens is, let's go with 1.6 times 10 power minus 19 coulombs. अच्छा, what happens is, if you have 1 mole of electrons, तो उसका क्या मतलब है? How many electrons do you have? That means you've got 1 mole. 1 mole particles कितने होते हैं? That's Avogadro's number. That's 6.02. So that means you have these many electrons, right? If you have 1 mole of electrons, that's 6.02 times 10 power 23. So if you have 6.02 times 10 power 23 electrons, and each electron has a charge of what? 1.6 times. अच्छा, sorry, मैं share ही नहीं किया हुआ था. अच्छा, each electron has a charge of 1.6 times 10 power minus 19 coulombs. मैं फिर से रिपीट कर दूं, मैं शेयर ही नहीं कर रहा था और किसी ने मुझे बताया ही नहीं. Remember, one electron has a charge of this. If you have 1 mole of electrons, that is 6.02 times 10 power 23. That's the number of electrons you've got in 1 mole. And one electron has a charge of this. So 1 mole of electrons पे क्या charge होगा? You basically multiply these two things. And when you multiply these two things, what do you get? You get 96,500 coulombs, approximately. So you get 96,500 coulombs. तो दो चीजें याद रखनी है. 1 electron पे charge क्या? That's 1.6 times 10 power minus 19 coulomb. And if you have 1 mole of electrons, the charge is 96,500 coulomb. Is that part clear? ये clear है?
Yes, sir.
Yes.
अच्छा, फिर उसी में ना, उसी से related is so basically this is known as the Faraday constant. ठीक है. So remember, what is the Faraday constant? कि 1 mole of electron पे charge क्या? That's what the Faraday constant is. The formula for Faraday constant is F is equal to LE. That's exactly what we did. L is the Avogadro's number, or constant, and E is 1.6 times 10 power minus 19 coulombs. ठीक है, that's it. That's Faraday constant. What do you do with the Faraday constant? वो मैं explain कर देता हूँ. There's another formula that you have already studied in physics. Physics में एक formula किया था, Q is equal to IT, जिसमें T जो था ना, that's time. So it's basically current into time. तो आपका the question, the moles question is exactly the same, except for you're going to have these two extra formulas. One is Q is equal to IT, which is physics. Okay, if you want to find the total charge that's flowing through a circuit or through an electrolysis or through an electrochemical cell, if you know the current, you know the time, you can figure out what the charge is. And the second one is the Faraday constant. The Faraday constant is the charge on 1 mole of electrons. So questions normally बहुत straightforward होंगे. ठीक है. So for example, I'll just do a very straightforward question. Okay, calculate the mass of copper deposited if what happens? Cu कौन सा? CuSO4 is electrolyzed for 2.5 hours with a 0.5 ampere current, बल्कि 0.05 ampere current. ये क्वेश्चन है. I even know the reaction. ठीक है, the reaction is कि अभी हमने लिखा था equation, copper plus 2 electrons and it will form. So that's the reaction. तो अच्छा, so it's the same moles question except कि you just got these two formulas. First thing, time पता है और क्या पता है? वो पता है. Current is known. So what can you find? You can find the charge that's flowing through the circuit. Current into time, ठीक है? Current कितना है? That's 0.05 amperes and time is 2.5, which वो seconds में होना चाहिए. 2.5 times 1 hour is 3600, I think. तो ये जरा calculator पे कोई somebody just quickly tell me what the value is.
$450.
इसका मतलब there's 450 coulombs flowing through the circuit, right? For in 2.5 hours. अच्छा फिर, so that's it. ठीक है, Q is equal to IT. Now you got the Faraday constant. With the Faraday constant, what you can do is, remember Faraday constant क्या है? 1 mole of electrons, उसका जो charge है ना, that's 96,500 coulombs. बल्कि ये क्या लिखा है मैंने? 96. दो मिनट और मुझे देना. 96,500 coulombs, right? So the where would it be helpful? If you know the electrons, you can figure out the charge. If you know the charge, you can figure out the number of electrons. Ratio है ना basically कि 2 moles होगा तो charge double होगा, ठीक है? So if you have 450 coulombs, I know that 96,500 coulombs अगर होते हैं ना, that's the Faraday constant. I know that I got 1 mole of electrons. So if I have 450 coulombs of electrons, so how many electrons do I have? वो क्रॉस मल्टीप्लाई करो तो क्या आता है? दैट्स 450 डिवाइड बाय 96,500. कितने मोल्स ऑफ इलेक्ट्रॉन्स आते हैं? ये कोई बता दे. How many moles of electrons do I get?
So 4.66 times 10 power negative 3.
So I'm getting 4.66 times 10 power minus 3 moles of electrons, right? The equation में I figured out how many electrons do I have. And electrons और copper का क्या ratio? It's 2:1, right? So the moles of copper are going to be half of this. मतलब 2 electrons होते हैं तो 1 copper होता है. अगर 10 electrons होंगे 5 coppers होंगे. So if you have these many moles of electrons, you're going to have half as much copper. तो कितने moles आ रहे हैं?
2.33 times 10 raised to power minus 3.
अच्छा, वो 10 raised to minus 3 moles. अच्छा, so you found the moles. If you want to find the mass, you can multiply it by the MR, which is I think 63.5. तो mass पता लग जाएगी. What is the mass that you get?
So 0.148.
Let's say we're getting 0.148 grams, ठीक है? So this is just an example. It's going to be mostly, it's a very straightforward, simple question. इसी तरह का. So just remember that if current and time are given, you can figure out the charge. If you know the charge, what can you do with the Faraday constant? If you know the charge, you can find the moles of electrons. So if you know the charge, you can figure out, you can convert the charge into moles of electrons. So once you know the moles of electrons, वो फिर equation में you can, equation में ना किसी एक की भी moles पता लगे ना, that means you pretty much by using ratios you can find the moles of everything in the equation. तो वहां पे फिर बात खत्म हो जाती है. Find the moles of copper, you can find the mass of copper as well, ठीक है? तो इसी तरह के बस बहुत basic questions around Q is equal to IT and Faraday constant are going to come, ठीक है? तो आई एम प्रीटी श्योर कि अब वही मेरे ज़हन में था कि कोई चीज़ बीच में ना मिसिंग है, दैट्स व्हाई आई वांटेड टू, तो वो हमने वी डन विद द फैराडे कांस्टेंट, सो वी डन विद इलेक्ट्रोकेमिस्ट्री, तो नाउ वी जस्ट गोइंग टू प्रैक्टिस पास पेपर क्वेश्चंस, ठीक है। तो वो सारी चीजें हमने कर ली, वी जस्ट गोइंग टू प्रैक्टिस पास पेपर क्वेश्चंस, वो फिर कल स्टार्ट करेंगे, ठीक है। तो इस पे तो कोई क्वेश्चन नहीं है, क्लियर है?
Yes.
चले, कल बात होती है, ठीक है।
Thank you, sir. Hafiz.
ओके, ठीक है।
La